roots of auxiliary equation corresponding CF. First one real root, say m1. Answer is C1 e power m1x, exponential m1x. 2. Two distinct real roots, say m1 m2. C1 e power m1x plus C2 e power m2x, extension. Just if you remember the first one, then it is extension rule. Okay. Similarly, you write later 3 distinct real roots m1 m2 m3, m1 m2 m3. Later you complete. So these 3 belongs to distinct nature, different nature, type 1. Okay. Next, 2 equal real roots, say m1 m1. Answer is C1 plus C2x e power m1x or C1x plus C2 e power m1x. 5. 3 equal real roots, say m1 comma m1 comma m1. C1 plus C2x, just extension to this, C3x square exponential m1x or C1x square plus C2x plus C3 times exponential m1x. These 2 belongs to type 2. 6th one pair of complex conjugate roots, say alpha plus or minus I beta. Alpha is e power alpha x into C1 cos beta x plus C2 sin beta x. Or you can write this is C1 times e power alpha x cos beta x plus C2. Equal pairs of complex conjugate roots alpha plus or minus I beta comma alpha plus or minus I beta e power alpha x into C1 plus C2x cos beta x plus C3 plus C4x sin beta x. These 2 third type. Last one, roots of the form alpha plus or minus root beta. Thirds are irrational numbers. E power alpha x into C1 cos h hyperbolic root beta x plus C2 sin h root beta x plus C2. Now, let us start with distinct roots. One real root, say m1, while solving a problem, if you get 0 or 1, one real number, then what is the answer for CF? C1 times exponential m1x. If you get two different real numbers, say m1, m2, root 2, comma root 3, 1, comma 2, like that, answer is extension to this. That is, the number of roots is nothing but number of arbitrary constants. Three different real roots, m1, m2, m3, just extension. I left to you. Later you complete. This is type 1. Type 2, equal case. Two equal real roots m1, m1, 1, comma 1, 2, comma 2, minus 3, comma minus 3, like that, 0, comma 0. Then answer is C1 plus C2x times e power m1x or C1x plus C2 times e power m1x. Either ascending powers of x or descending powers of x. Okay. Whenever 3 times equal m1, 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 just extension. Here it stops at x. Now here it is going to stop at x square. 2 times equal, you will be getting x power 1. 3 times equal, you will be getting x square. Just observe number of roots is equal to number of arbitrary constants. These are type 2. Type 3. One pair of complex conjugate roots. What is pair of? Pair means two roots. Complex conjugate roots means, for example, 1 plus I is one root. Automatically 1 minus I is also the roots. Put together in the form of 1 plus r minus I. Let us denote that pair by alpha plus r minus I beta. Alpha is before plus r minus, beta is I multiplying term. Alpha is real part, beta is imaginary part. So answer is exponential alpha x times C1 cos beta x plus C2 sin beta x, or using trigonometry you can write e power alpha x into cos beta x plus C2 or e power alpha x into sin beta x plus C2, like that before. Next, whenever two equal pairs, two pairs means 4 roots, equal pairs. One pair is alpha plus or minus I beta, other pair is also denoted like that. Totally 4 roots. Your answer containing 4 C1, C2, C3, C4. Just using merge this formula and this formula, 4th and 6th. 4th tells that one pair, 2 roots equal, 6th tells that one pair. Combining these two, you will get this one. Okay. Now the last 8th one is 4th type, roots of the form alpha plus or minus root beta. That means you can compare this with m1, comma m2 after separating plus or minus. So, due to options, okay, this is considered as separate rule. Exponential alpha x into C1 cos hyperbolic root beta x plus C2 sin hyperbolic root sin x. Sin hyperbolic root sin beta x. Cos hyperbolic root beta x, sin hyperbolic root beta x. The difference here, trigonometry, here sin cos, here hyperbolic sin cos. There beta I gave beta x. Here I wrote root beta, that's why inside term is root beta. Every other thing is similar. Just by heart all these 8 points. So answer for this, what I left to you, C1 e power m1x plus C2 e power m2x plus C3 e power m3x. So against to each nature, I have given the CF. So In all these, you observe first point is order of the differential equation is equal to number of roots in the auxiliary equation is equal to number of arbitrary constants, that is C1, C2, C3 so on, in the general solution or in the complementary function. These three always equal. Second point, sometimes in the options of your problems, instead of C1, C2, it may be denoted by some A, B, C, alpha, beta, gamma, or K1, K2, K3. These are the two first observations while solving the problems. After 2 to 3 problems, I will give you some important note point also. Linearly independent, dependent, which we already discussed in Common Maths matrices chapter. The same treatment. Solve the following. Just here I am writing. First problem. D cube minus 3d square plus 4 times y is equal to 0. 2. This is given 2008. X double dot plus 3x equal to 0, comma, x of 0 is equal to 1 and x dot 0 is equal to 0. What is x of 1? Question mark. Third problem. Which is given 2013. The maximum value of y of t of the differential equation y of t plus y double dot t is equal to 0 with initial conditions y dot 0 is equal to 0 comma 1 comma y of 0 is equal to 2 for t greater than or equal to 0, comma is. First problem. So before solving these problems, your first step, writing in the form of standard notation and in capital D notation, operator form. Standard notation means dependent variable terms on left side, if any other terms on the right side. If your right side 0, that is called f of d into y is equal to 0, otherwise f of d into y is equal to capital X. So first problem, given equation already in standard form, d cube minus 3d square plus 4 into y is equal to 0. So first variable is y, derivatives are all for y variable, with respect to it is not mentioned. So whenever first is y, dependent variable y, automatically take the second variable as x, okay, if it is not mentioned, or according to the options you take the independent variable like that. So here I didn't give the options, so that's why I am taking the original variable independent x, that is d by dx, your capital D. Next step is auxiliary equation. M cube minus 3m square, what I told, this is your f of d, put d is equal to m and equate it to 0, okay. Now this is a cubic equation, here a constant and plus 4 is 0, so no root is 0. How to solve? I solve one problem in lambda equation, that is eigenvalue eigenvectors problem. Okay, solving a cubic equation. First, trial and error method. So give one by one integer to m. So whenever you will get one answer, other answers roots are obtained by synthetic division or Horner's method. So here m is equal to 1 not satisfying, m is equal to -1 satisfies. So one of the roots of the m values are -1. Others are obtained by synthetic division. M cube coefficient 1, m square coefficient -3. Here m is absent. I can take corresponding coefficient is 0 and the constant term coefficient is +4. Here before that margin put first root. What is that first root? -1. In the second row first element is always 0 and add the elements column wise. After that answer, that means after adding the value obtained which is multiplied with every time first root. So every time you adding column wise and that answer obtained multiplied with your -1 first root. So that is our procedure in the second step. So 1 into -1, -1, -3, -1, -4, -4 into -1, +4, 0 + 4, 4. 4 into -1, -4. Last indicates why I put that symbol, that is an indication, remainder 0. What is the meaning of remainder 0? Whenever this m + 1 dividing this equation, this is called quotient. Quotient, remainder, divider, divisor, factor theorem, that is which we have studied in childhood classes, low level classes, that is low standard classes. That is 6th standard, 4th standard, 5th standard, that is synthetic division. Okay, so therefore the quotient is here m square minus 4m plus 4. Already it is m cube equation, we got one m value, so starts with multiplying m square respectively and decreasing by power 1, m square, m and then constant. Okay, so these are the factorized. This equation is factorizable whose factors are m minus 2 into m minus 2, or you can solve every second degree equation by quadratic equation method. So finally what we got the roots, m is equal to -1, 2, 2. Here one single root, real root. Here the other two real roots are equal. So in the table this is first point, in this fourth point. Therefore because of right side 0, what is general solution I have given? That is your dependent variable y starts with, what is general solution? Starts with dependent variable equal to, what is your solution name? CF. What is CF? Complementary function. According to the table, with these three roots, what is the answer? One real root -1 C1 e power m1x, that is -x. Next two roots m1 m1. Already m1 I compared with this -1. So compare these 2, 2 with m2 m2. That is fourth point. So C2 plus C3x, because C1 is occupies in the first position. Then next if any constant continuing, that is successively only C2 plus C3x e power 2x. This is the answer. Constants can be written like that only, arbitrarily, but no problem, you can write any, order is also you can change, that is because they are taking any values, arbitrary constant, any small value, large value, 0, non-zero, anything. So second one, here one of the variable is x, second variable is not mentioned. One dot stands for one derivative, two dots stands for second derivative. With respect to second variable is not mentioned, that is independent variable. So you take as t, because that is x and t one combination, y and x other combination, like that. Generally I am speaking like that. Or otherwise depending on the options only you take, depending on the solution of the options you take that second variable. Okay. So given equation is d square x by dt square plus 3 times x is equal to 0. That is d square plus 3 into x is equal to 0, where d stands for differentiation with respect to t. I have taken the independent variable as t in this. Auxiliary equation, m square plus 3 is equal to 0. So m is equal to plus or minus root 3 I. 3 going to that side minus 3, square going to that side square root. Before square root put plus or minus, because square root containing minus 1, that's why I put I. I is imaginary. So it is in the form of alpha plus or minus I beta, sixth point in the table. That means alpha 0, beta value root 3. Therefore, because right side 0, your solution is x is equal to CF. In the previous problem, y is equal to CF. Why we are getting here x is equal to CF? Here the derivative is for x variable. X is dependent variable. So your solution starts with x is equal to CF. What is CF? In terms of t variable. Your independent variable is t. I have given the table in terms of x because I consider the equation in the definition dy by dx. Now it is d by dt. Just in table replace x by t. You will be getting CF. E power 0t, e power alpha x, x means t, into c1 cos beta x, beta means root 3t, plus c2 sin beta x, beta means root 3, x means t variable. What is e power 0t? This is gives 1. So let us say this is equation 1. Go to your problem. There are some conditions, initial conditions. One condition is x of 0, other condition is x dot. So for this obtained value of x, you need to find x dot, which implies x dot. What is x dot? Dx by dt. This is nothing but derivative with respect to t. Cos derivative minus sine, sine derivative plus cos. So minus root 3, c1 sine, root 3 comes out, plus root 3 c2 cos root 3 3. Let us say equation 2. Y of, sorry, what are conditions given? X of 0 is equal to 1 and x dot 0 is equal to 0. That is x is equal to 1, t is equal to 0 and x dot is equal to 0, comma t is equal to 0, comma 1 and 2 gives substitute these values in 1 and 2. 1 and 2 gives Now substituting the conditions, x is equal to 1, t is equal to 0, c1 cos 0 1, sin 0 0. From this c1 is equal to 1, and in the second equation x dot value 0, t is equal to 0, minus root 3 c1 sin 0 0 plus root 3 c2 cos 0 1. From this c2 is equal to 0. So substitute these two values back into the solution. Therefore 1 becomes, equation 1 becomes x is equal to cos root 3 t. Equation 3. What is finally required? X of 1. So x is equal to question mark t is equal to 1, comma 3 gives how much? Substituting these values in 3, that is 3 gives x is equal to cos root 3 minus 0.16 etc. approximately like that. Okay. just calculate through calculator. This value cos root 3 will be minus 0.162, 1601 or 162 approximately, I don't remember. Later you check. Just write here, add one more problem. Y double dash plus 2y dash plus y is equal to 0, comma y of 0 is equal to 0, y of 1 is equal to 0. What is y of 0.5? For this, answer is 0. Y of 0.5. Here these type of conditions are called boundary conditions. Y of 0, y of 1, x value, bracket value changes. As above, I calculated C1, C2. Here also you calculate C1, C2. But in this problem, not required y dot. As above, I calculated x dot, dx by dt. Here not required because boundary conditions are given. So here I am giving into C1 0, C2 0. Therefore, y is equal to 0. Therefore, y of 0.5 is equal to 0. Y of, that is y is a null solution. Y of any x value is also 0. You please check fourth part. Now I am doing third problem. So given equation y double dot, that is I am writing capital D notation, both variables are mentioned, d square plus 1 into y is equal to 0, capital D is equal to d by dt. Okay. So as above, same auxiliary equation, m square plus 1 is equal to 0, m is equal to plus or minus I, alpha 0, beta value 1. Therefore, general solution is y is equal to CF, that is e power 0, as above same, e power 0 value becomes 1, C1 cos t plus C2 sin t. Let us say equation 1. As above, just see x and t there, here y and t variables. Next y dot, that is dy by dt, which is nothing but derivative, minus C1 sin t plus C2 cos t, equation 2. Now what is this? Y value 2, x t value 0. Okay. First condition. And what is second condition? Y dot value 1, t is equal to 0, comma 1 and 2 gives. Substitute here, you will be getting 2 is equal to C1 and 1 is equal to sin 0 0 cos 0 1 C2. So therefore y is equal to 2 cos t plus sin t. You know how to find maximum minimum for one variable y in terms of x, we have discussed in M1 paper. Okay, answer is, later you check, answer is root 5. the maximum value is root over 2 square plus 1 square. Just applying 11th and 12th standard method. Okay, whenever an expression a cos x plus b sin x plus c, that for that expression your maximum value is c plus root over a square plus b square. Okay, so this is equal to root 5. Or just apply first derivative, equate to 0, find t values, find second derivative, substitute t value, find the maximum value, which we have adapted. That means we already learnt in the max 1 paper, maximum minima for one variable x, here it is t. Later you check. A fifth problem giving the complete solution of the differential equation y double dash plus a times y dash plus b times y is equal to 0 is y is equal to c1 plus c2x into e power 2x. Then the values of a and b are. So in the fifth problem, differential equation is given, solution is also given, but we have to find a, b values. See the solution. CS or GS, general solution or complete solution, both are having same meaning, is y is equal to c1 plus c2x times e power 2x. So it looks like in the form of this CF, your fourth point in the table. Okay, c1 plus c2x into e power m1x, just give an indication like this. So therefore I am doing this problem by back to pavilion, last to first step. Okay, so far we have solved the problem first step to last step. First step is auxiliary equation, then roots, then CF. Now it is CF is given, go back, that is go to reverse. Okay, roots are 2 comma 2 equal roots. Therefore what is auxiliary equation, or you can directly write differential equation also, m minus first root into m minus second root. Generally in all the previous problem, how you obtained m values after factorizing. Okay, so whenever you know the roots, just multiply the corresponding factors. What are the factors? M minus first number into m minus second number, then only you will get the equation. So this implies m square minus 4m plus 4 is equal to 0. Therefore differential equation d square y by dx square, capital D notation. What is capital D notation? D square minus 4d plus 4 into y is equal to 0. What is d square? Y double dash minus 4 times y dash plus 4 times y So therefore A is equal to minus 4, B is equal to 4. Next note, first one. AE is also given by f of d is equal to 0. Without m notation, some others are in some textbooks they have given f of d is equal to 0, solving the d values that are called roots of the auxiliary equation. Without m notation, some textbooks they have given directly f of d is equal to 0. Okay. Next, if y is equal to y1, y is equal to y2, so on, y is equal to yn, or n li means full form, linearly independent solutions of the differential equation f of d into y is equal to 0, then y is equal to c1 y1 plus c2 y2 plus c3 y3, that is plus etc. cn yn is also the solution of f of d into y is equal to 0. And this term is nothing but linear combination of the solution which is already defined as CF. So individually some n solutions are there of the given equation. Their linear combination also is also a solution. That solution is already defined by complementary function. Okay, because instead of option, that means after solving the problems in the given questions, your options not like that, c1 into something, c2 into something. Option A x square, option B x, option C is e power x. That is c1 coefficient, c2 coefficient, so on, cn coefficients. All coefficients of c1, c2, they are also the solutions of the equation whose right side 0. That is y1, y2 are also individually satisfying that f of d into y is equal to 0, that solution. And you know the linearly independent, linearly dependent. Okay, just we have discussed in vectors. Third point. So there is a short method procedure for saying your solutions are linearly independent or not. Okay, that is invented by Wronskian scientist. Two solutions y1, y2 are said to be solutions or some functions. Okay, are said to be linearly independent if w is equal to determinant y1, y2, y1 dash, y2 dash not equal to 0. So W is a scientist, that is Wronskian, W-R-O-N-S K-I-A-N, K silent, Wronskian. So he invented the procedure through determinant shortcut method, linearly independent solutions or functions. Determinant not equal to 0, independent. Determinant equal to 0, dependent. We have discussed the same thing in vectors also. I mean vectors means matrices. Okay. Fourth one. Three solutions in brackets functions y1, y2, y1, y2, y3 are said to be linearly independent if W, Wronskian, is equal to determinant y1, y2, y3, y1 dash, y2 dash, y3 dash, y1 double dash, y2 double dash, y3 double dash. 3 by 3 determinant not equal to 0. Similarly, etc. And so on. Next I am giving short method procedures for PI. Particular integral. So what is PI I have given? 1 upon f of d, 1 over f of d into capital X. So there are some standard functions of the right side of the problem, that is capital X. There is a corresponding short method rules for finding the particular integral, PI. Rule 1. 1 over f of d. Your first right side term of the problem is exponential quantity, e raised to ax plus b, that is e power x, ax plus b. A, b are constants, is equal to 1 over f of a e power ax plus b. That means what I have done here, that is put d is equal to a when f of a not equal to 0, because f of a is a number which came into the denominator, that is not equal to 0. Suppose while calculating this f of a after putting d is equal to a, you may get 0 in some problems. If f of a is equal to 0, then 1 over f of d into e power ax plus b is equal to x times 1 over f dash d into e power ax plus b. And this simplifies to x into 1 over f dash a into e power ax plus b, comma, when f dash a not equal to 0. If f dash a is equal to 0, then repeat the above process. Now your right side of the differential equation, what is the differential equation here? Of, or you can write of the differential equation, non-homogeneous equation f of d into y is equal to capital X. Your right side first capital X term is of the form exponential quantity like e power ax plus b, e raised to ax plus b. So x coefficient is a. What I have done the procedure? In d, put d is equal to a. So this is a number denominator. In the fraction, the denominator not equal to 0. That's why I assumed the condition. Sometimes in calculating this f of a, you may get 0 in some problems. Whenever f of a is 0, then what is the rule? This is your particular integral. What is the answer? First, pre-multiplying by x. First write x, then go to denominator, find the derivative. Becomes f dash d into e power x plus b. Again apply the rule. That means whenever denominator containing d terms, apply the rule. What is the rule? Putting d is equal to a. So as long as, that is until to reach the denominator free of d's and a non-zero term, non-zero constant. Okay, until to reach non-zero constant in the denominator free of d terms. Up to that you always apply putting d is equal to a, putting d is equal to a. Whenever it is not equal to 0, the problem is over. Whenever it is equal to 0, you pre-multiply by x. That means what we are doing generally, pre-multiply by x as many times as the denominator 0 after putting d is equal to a. What is the procedure? Putting d is equal to a. What is that a? X coefficient. Okay. Repeat the above procedure. Here whenever this is equal to 0, not equal to 0, I took, whenever it is equal to 0, then repeat the above process means like this. So just remember putting d is equal to a so that denominator not equal to 0. Then only you put. Otherwise you pre-multiply by x and denominator derivative and apply the above process. Now rule 2. So for understanding purpose, procedure purpose, instead of f of t, I am denoting by f of d square. In textbooks it is denoted by phi of d square, like that. Either sine of ax plus b or cos of ax plus b. Either sine function or cos function, but not both. That means both means not in the multiplication. Either sine terms or cos terms. This is equal to 1 over f of minus a square into sine ax plus b or cos ax plus b, depending on the term. What I have done, that is what I put d square is equal to minus a square. Put d square is equal to minus a square. When the condition is the denominator f of minus a square is now constant, that constant not equal to 0. Same procedure, a small change. In rule 1 I put d is equal to a. In rule 2 put d square is equal to minus into a square. Again a is nothing but x coefficient, the multiplication term to x. In rule 1 e power ax plus b, in rule 2 sin ax plus b or cos ax plus b. Sometimes the denominator may be 0. If f of minus a square 0, then the particular integral 1 over f of d square into sine ax plus b or cos ax plus b is equal to, just as above rule 1, first pre-multiply by x and go to the denominator, find the derivative into sine ax plus b or cos ax plus b. Just the same as above rule 1, only the change is put d square is equal to minus a square. So again here also getting x into 1 by, again put minus a square for d square into sine ax plus b or cos ax plus b. When f dash minus a square not equal to 0. Similarly as above, if f dash minus a square second time also 0, then repeat the above process. First of all, in some textbooks it is denoted by phi of d square. For understanding purpose I have denoted f of d square only, either sine or cos. Again x coefficient is a. Procedure is I kept in the bracket, I wrote in the bracket, put d square is equal to minus a square. So f of minus a square is a number. Whenever in a denominator, that is whenever in a fraction, the denominator, that is if anything, it should be 0 or not equal to 0, you only tell. If a fraction is there, the denominator is 0 or not equal to 0, denominator not equal to 0. While calculating, that is putting d square is equal to minus a square, you may get 0. Then this is the procedure as above. Put x, first write x, pre-multiply by x and denominator derivative, and again put d square is equal to minus a square. Again this not equal to 0. Second time also equal to 0, repeat the above process as above. Rule 3. One over f of d x raised to m. M is a positive integer. That is 1, 2, 3, 4, etc. In this rule, expand 1 over f of d, that is f of d whole power minus 1 in terms of d by binomial expansion or binomial theorem. Okay, I will continue.